In this video, we are going to go through a word problem that has a couple questions associated with it. So let me kind of read it through it. It involves a log. That's kind of what the idea of the video is. So it says the loudness of a sound is measured by a unit called a decibel. A very faint sound called the threshold sound is assigned the intensity of I naught. Okay, so that's our initial kind of sound. Other sounds have an intensity of I, which is a specified number times the threshold sound. So, well, we do. So I is going to equal some value times this initial sound. And then the decibel rate is given by the formula decibels equals 10 times log of this intensity divided by an initial intensity. Find the decibel rating to the nearest decibel for sounds. Right? So a whisper is the way this reads is this initial sound is basically a very, very, very faint sound, but a whisper would be 110 times more intense. So the idea is that I equals this. So our intensity is 110 times the initial faint sound. So to figure out the decibels to it, we're going to say that our decibels, and I'm just going to plug things in, it's going to equal 10 log our intensity, which is this, 110 initial divided by initial. And so these two go away. So what you're really doing is 10 times log of 110. And we'll see what that equals. And we're going to round to the nearest decibel when we do this. So we're going to plug in 10 times log of 110. And so that's about 20 decibels. All right, so a whisper is 20 decibels. And then if we go to the next one, a speaking voice, so just a normal voice, it has an intensity that is 225 times more intense than a very, very faint sound. And so our decibel on that is 10 log 225 times an initial divided by initial. Well, if you've kind of noticed that this is going to happen every single time where these are going to go away. And so we're really just left with taking 10 log 225. All right, so 10 log 225. And so that is about, so just a regular talking versus a whisper is about 24 decibels. All right, and then the last one is a plane taking off. Plane taking off is, so this intensity, a little more space, is billions, billions, trillions, 109 trillion times more intense than the faintest sound you can hear. So we got 1, 2, 3, 4 chunks. Okay, and then times this initial amount. But I'm going to save a step that when I throw this, is going to go in the numerator divided by the same thing. These are going to cancel. So it really is just going to turn into the decibel is going to equal 10 times log of 109 trillion. And we're going to see what that is. So 10 log 109, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Close my parenthesis. We get about 140 decibels. So that's the thing with logs. Very, very, very large numbers with logs don't equate to very, very large outputs. And that's going to be kind of shown a little bit in the graph, but that's just the idea of logs. That's how logs work. So that was a word problem that kind of involved a situation, an equation that involved logs, and just making sure that we're okay with the setup and how to plug it into account.